On this episode of the podcast, I have with me Engin Anil. He's the VP of Software Engineering at Gatik. We're going to be talking about a couple different things, but mainly around data complexity, data volume within the autonomous vehicle space. It's a really complicated area. I've drawn the analogy of what's happening there is as complex as the logistics behind an airplane flying. These are real world, serious impacts, and there's a lot of complexity that goes into how these applications are written. Engin's got a great background to talk about that. I'm excited to have you on the show.
Thanks so much, Amir. I'm looking forward to sharing some of my experience in this area since I finished my PhD in 2014 and talking about these very interesting topics.
Awesome. So let's talk a little bit about some of the, I guess autonomous vehicles, right? Let's start off at the top. Everyone knows of autonomous vehicles. We've all seen the pictures of, how a Tesla is processing data, all the blinking lights, and it seems pretty difficult. If you're in technology, if you're outside technology, these are some sophisticated piece of technology that's happening. And I think obviously, I think most people have flown a plane. We have complete confidence. Get on a plane for the most part, you expect to land. Autonomous vehicles are still a work in progress. Like we have to get to the point where people are sure and they're that confident. That seems like a big shift in the way the world would be. And the complexity that goes in it is part of your job in delivering that software. Maybe at the highest level, talk to us about some of those impacts, right? Like let's talk about at the highest level, is there an analogy that's similar to how Boeing or Airbus have to code their planes to manage all those risks and factors in a groundbreaking environment?
There are some similarities to what we know from the other industries, such as aviation, and there are some very big differences in how the autonomous driving technology would apply day to day.
Awesome. Let's, I guess, help us understand just to set some context as a good analogy of obviously we're all, we have a sense of how aviation has advanced. It's been around for so long. It's mature. In the autonomous vehicle space, we're still developing technology. We're still testing it. If you're ever in the Bay Area, you see all the autonomous vehicles being tested and driven around. Talk about that maturity process to start with.
The biggest question, we have to answer, or one of the biggest questions, is safety. How do you prove the safety of an autonomous vehicle in an environment where most of the agents currently are human drivers? We have rules of the road that give us some predictability about what should be happening around us, but that is never guaranteed. So we still need to solve the general problem of autonomy if we want to put a vehicle on the road and behave in an environment and work with the other human drivers and potentially other autonomous agents in the environment. And of course, along with that comes the problem of where does this data come from? How do we make sense of it? How do we make decisions on the go as fast as a human would, or even faster than a human could?
Yeah, and I imagine, I guess within the aviation space, it's all been airplanes the whole time. But you have helicopters and stuff like that, but there are no individuals that you have to adapt around. Whereas in the autonomous vehicle space, you already have several decades of individual drivers, and you're trying to mix in the autonomous vehicles within that, which seems to be an additional wrinkle, because it's not that you just have to know the information or data points from another plane and where it's going and keep the distance and balances all those factors. An autonomous vehicle has to process other autonomous vehicles that probably might be simpler to a degree, but it also has to start anticipating how thousands of different individual drivers might react versus them just being machines. And that seems to be, when I think about this, seems to be like I don't even know how you get there, but obviously you guys are working on it.
Absolutely. It's a very complicated problem. One, there are the complications of the built environment that we are trying to drive in. And to be honest, sometimes you won't even have that kind of structure in the environment. So like, what if the lane lines are missing, right? And Sometimes, even I, as an experienced human driver, I see an intersection the first time, I am confused. Which traffic light should I be paying attention to? Which one is my red? Which one is my green? That is one. The other thing is, in the real world, as you said, we have so many different types of agents that we have to deal with. The way you would interact with a law enforcement or an ambulance is very different from how you would interact with the with another random individual driving their vehicle on the road. But to an outside observer, for example, like this is a funny example I give in my interviews. The plumber who fixes my house is driving the exact same kind of red truck as an ambulance. How does a machine tell the difference between the two? It's what we call the long tail problem, and there is where most of the challenges are.
That's interesting. Yeah, because I think a lot of people, when they think about aviation, rail, boats, we don't even really think about these things for the most part. The problems have their own defined, I guess, environments. The variables are seemingly known. Obviously, different conditions. You just described this, interesting scenario where, yes, the guy who's the plumber versus an ambulance, the shape of the truck similar, and there could be two of them side by side driving on the road or crossing each other, and potentially one with lights on, one without the siren on. And how do you pick up the difference between the two? That seems like a tremendous amount of data. I mean, our eyes are picking that up, we're processing it. But when you're talking about an autonomous vehicle and that level of data that's happening, how fast does that happen in real time? Like, how quickly is that decision made by an autonomous vehicle?
It will have to be obviously very quick. But then when we are thinking about the autonomous vehicle, the autonomous system, there is the time to detect, there is a time to process and make a decision, and then there's a time to act, right? Obviously, it will have to be much faster than a human, whereas like our system is contained within our skulls and we are able to make very fast decisions. So we are talking about milliseconds.
This, I guess, you've been in this space. Obviously, the people that sit on these teams solving these problems, some of these roles are similar across different fields. I mean, the machine learning, AI, computer vision, these are similar people working in environments. This environment, working and factoring this millisecond, sub-millisecond decision-making process, does that affect the type of engineering that goes into place? Like, it seems to be obviously a niche experience or expertise, but how does that affect the type of people that work on these problems?
Absolutely. It's always when I think about solving these kinds of problems, I always think from the perspective of a product. Like, how do you develop an algorithm? First, understand the problem, build the algorithms, and turn it into a product. And each of these steps require a different kind of skill set, different kind of thinking. If we put the problem that you just described, making sense of the world, into the context of a self-driving system, we are usually talking about the problem of perception. That is, making sense of the world, making sense of the other agents in the environment, so that we can make decisions about the state of our vehicle and our vehicle's actions in relation to the world around us. And to solve this problem, you will see a couple different areas of expertise. One is building the algorithms. Usually you see deep learning, machine learning, computer vision experts working on that field. These folks, more often than not, have advanced degrees in these fields. The second one is, now we have to build the algorithm. How do we turn it into scalable, maintainable software? Sometimes the target environment that these algorithms will have to run on will be different from your development environment, like the developer's laptop versus some dedicated embedded system in the truck. On the second class of problems, usually you have software engineers working on it. And the last class of skill set is usually like the MLOps skill set, delivering and maintaining these models, and making sure that the right models are used at the right time.
I guess when we're looking at, because you mentioned the perception problem and in the type of person that works on them. So obviously, I have a mobile app. I can scan a product, and my shopping app will go try to identify whether or not they have it in stock, all those things. it seems like that, it's for, let's say I'm looking at a box of cookies and I want to see if they have it in stock. Okay. I mean, it could take a second. It doesn't matter. There's nothing to it. In this case, what the person developing the technology, they have to handle this, I guess, this millisecond, this time constraint, the urgency and being able to bring back that response or answer and be correct. Obviously, PhD degrees are pretty standard when you're dealing with a lot of perception type roles. How is it different? Like, let's say, can someone who's working on an app for, let's say, eBay, Amazon, who deals with computer vision, transfer those skills to autonomous vehicles? Or is it even a further specialization and training that you need to kind of handle the context of what you're doing?
80-90% of the time, the skills will be transferable. For example, if you are talking about computer vision, deep learning kind of research kind of role, let's lump them all into one. You're talking about experience in photogrammetry and traditional computer vision techniques and optimization and deep learning. These are pretty standard across many fields. But then, how do you bring that into a self-driving vehicle? It can be an entirely different problem, which usually requires a better sense of systems and safety, and how those requirements will flow into your perception system that you are trying to build. And that's where you will start defining the performance requirements and the speed of the algorithm and so on.
When you talk about safety and you're developing with that constraint in mind, what changes from the mindset of the engineer? Because not everyone is working on same type of fault tolerant system. I mean, not everyone does that in their career. It's kind of unique. In this case, it is a mission critical. It has to be very, not just secure, but it has to be fault tolerant. How does that change, I guess, the engineering itself? Like, in terms of, if you were to hire somebody that doesn't have that experience, how does one start working and understanding the constraints of that piece?
The research aspect of it will be mostly the same again, but then how do you develop that software, and how do we define the requirements around the software, and how do we test it so that we do not have certain kind of repeatable faults, for example? That will change. And once you understand that, then the rest of it is in building that software and testing it, and also showing it that we have done the work and we have followed all of the steps that are required by the state of the art. And these kinds of things are usually captured in safety-related standards. These are not the regulations that we have to follow, but they are the state of the art that have been developed in many other fields, such as automotive, which is very mature when it comes to building safe systems. Also, aviation.
So I guess we'll come back to that team aspect in a second. But I was kind of curious, as you're hiring people and people join, a lot of times it isn't just what has worked, the solutions. It's the solutions that have been tested that haven't worked that's really important as well. I guess when it comes to this space, when somebody joins the team, how does the person ramp up in understanding the history of, hey, what hasn't worked when we've tested these solutions for sub millisecond perception techniques, or the research that goes into the applied? How does somebody ramp up on that?
That is a great question. In your previous question, I kind of alluded to the standards and how you would show that you have done the work, so that you can present not only the results but all of the artifacts of the steps that you have followed. Hopefully, you will have the system in place so that the work that you have done is documented. It's all the way from this vehicle level to system level to individual modules. And all of the requirements will be traceable to the original questions and goals that you have set in your safety plan. So someone coming into this, actually, that would be a great test of your company's or your organization's practices. Can I drop someone into my organization? And can they figure out, starting from where we are right now, what was the original goal and how we got there? That would be an amazing test of your organization's safety goals or safety practices.
Absolutely. And I guess corresponding with that, when you guys are interviewing somebody for one of these roles, and obviously we mentioned that a lot of it's transferable, right? So maybe somebody not within the industry wouldn't know that, but you do the work, you interview people who do this type of work. It is very transferable. How do you test or kind of determine that final 10-20% of being able to take the core skills and translate them? I always draw the analogy that you can have hamburgers at all kinds of restaurants, but you necessarily can't take the same recipes and apply them in a different way. They kind of require the application, requires some different techniques, that kind of a different understanding and that implementation. So how when you're testing and evaluating people to join, how do you tell or how do you evaluate that they can translate that theory into the application that you need?
Mm-hmm. I look for two things. Using your analogy, I don't necessarily look at or only look at whether they understand their previous company's hamburger recipe, but I would look at whether they understand the ingredients, whether they understand the meat and cooking techniques. And that is what makes the knowledge transferable, right? Like changing the recipe means combining the ingredients in a different way and cooking them in a different way. The second thing I do is, so fundamentals first. The second thing I do is I try to approach the interview process with curiosity. What do they know that I do not know that they can bring into our team and make our team stronger? So that is the diversity aspect of it. Do they have some other skill that our team currently does not possess? For example, I worked with amazing engineers in the past coming from statistics background, not necessarily from machine learning background, but they understand the math, they understand how to apply it, and they can apply that knowledge very effectively in any environment.
Interesting. I like it. I think the hamburger analogy makes it easy for me to grasp. And I think that's actually interesting because I think people always. I worked with somebody once, and he said, McDonald's has it down to science where some teenager can make a hamburger, but that doesn't mean that teenager can move on into an actual role where they're at a restaurant making a hamburger. They're completely two different things, even though the product is the same. I think how you described it's interesting because the grasping that fundamental and the applications is very hard. And I guess if you're going to take that the next step forward, and you have to understand how these people will work with the next team, because obviously if you're coming in working for an e-commerce app on computer vision problems, coming to do that for Gatik and then understanding how to apply it, it's one thing we talked about, but also then how it relates to the other parts of the team, that has to be a different angle of complexity, I'd assume.
It is definitely a different level of complexity. And again, if you take the perception problem as our example, your perception module will have dependencies to its upstream. It will have to work with the sensors, the hardware itself, and it will also depend on the quality of the calibration of the sensors and the synchronized delivery of the data. And then there are things that it is responsible for delivering to its downstream. For example, if we want to predict what the other vehicles will be doing next, we need to identify the moving objects and also understand their motion and predict into the future. And we also need to, if we want to plan where we need to go next, we need to see and understand what's around us and how the vehicles will be moving and make certain decisions based on that. So there's a little bit of like cross-disciplinary, fair bit of cross-disciplinary work that needs to happen where common objectives are well understood between the teams. And two, be able to separate them enough that they can work individually without really making things complicated for cross-disciplinary teams.
So I guess in and I'm curious because I don't know the answer to this. I'm going to ask you. Maybe people out there are curious as well. So a lot of jobs, your job is to ship, and the end user is using the product, and you're shipping consistently. There's not as much testing, I guess, in a role, especially on these perception problem or researchers or people deeper in AI algorithms, stuff like that. Maybe they're testing a lot, not releasing as often, right? They're doing a lot of work that doesn't necessarily translate to a lot of success, right? Yeah, I don't know. They run 100 tests, one is successful. I don't know the numbers, so I'm just throwing it out there. How does an engineer in this space handle that? Because I guess engineer loves to build and loves to ship. In this case, there's a lot of research, a lot of testing, there's safety constraints. How do engineers handle that?
As you said, it's a very complicated problem. Like, one, we have to solve research problems, and some of these research problems can be pretty big and even span multiple teams and multiple disciplines. Right, so that is where really like being able to lead an organization very effectively, cross-functionally, comes into play. The other thing is, as soon as your company, your team grows beyond a certain number, then it will become impossible to really manage it team by team. That's where building really good processes, one, for managing your teams, and two, your safety practices becomes extremely important. So it turns into a game of building processes and making sure that they're efficient and making sure that you are following them.
I guess when you're kind of looking at your career, and obviously you're managing teams, you have a PhD within the space, you've worked on all these different type of issues in the last several years, and you're hiring people. Are you anticipating the kind of challenges an individual contributor is going to have in terms of ramping up, and how you can best help them be productive? Because I'd assume becoming productive, there's a ramp up time, and you gotta, again, we talked about the knowledge base, understanding what's already happened to be able to contribute. How do you kind of make that ramp up period more as efficient as you can?
There are a couple aspects of it. So for the sake of this conversation, let's assume we are building a brand new team, right? Like, we identified certain kinds of skill sets that we want to bring in. The place where I usually start when I'm considering or when I'm working on building a team is first defining, why does this team even exist? What will they do? How will they contribute to the solution of the problem? And to understand that problem, we really have to look at it from a product and company perspective, because the same team may exist, the exact same individuals may exist as a team for completely different purposes in two different companies. As you said, for example, take a computer vision machine learning team and put them into a healthcare company. Their work will be very different from that of the same team in a self-driving company. So we first need to understand that. And once you do that, then you can start talking about how to hire for these roles. And more importantly, now coming towards your question, is how to organize our teams and organize their work and set up systems and frameworks so that they can interact very efficiently with each other and learn and grow and be effective.
I always think of this problem space, and I joke. I go, I'd love to not have to ever drive myself anywhere. So I think when you get in an Uber, you sit in the back of an Uber, and you get someplace, and you were relaxing for 10, 15, 20 minutes on your phone, or just whatever you're doing, you realize, oh man, this is such a gain. And all these conversations with autonomous vehicles, you realize that a human can barely handle. That's why we have these don't text and drive laws. We can barely handle that, let alone being switched on constantly. Now we're asking machines to be able to do all that for us and deal with all the other people who are distracted, eating, drinking, all these other things. And I'm like, man, this is such a tremendous effort. And I guess when you kind of look at that, it seems like a huge thing, a huge ambitious. It is huge and ambitious.
It is very ambitious.
Yeah, it is very ambitious. But when you think about the magnitude and you start reflecting on that, how do you focus on the day-to-day? Because it's too easy. If you were starting to think about the big problem, obviously you're researchers, so I think your minds are more trained effectively. But how do you help the team stay focused on the individual little wins that they have to perform?
I look at two things. One, as a leader, I see my job as building a system of people so that we can build a system of hardware and software. Right? Without the system, with really good system of people, we cannot build any of these complex problems. So I see my job as an enabler in building that system and maintaining that system and making sure that it is as efficient as it can be and scalable and maintainable. The other aspect is focusing the team on the fact that this is teamwork. There is no you and me. We're in this together. And even changing my language sometimes when I'm addressing my team and when I'm addressing different parts of it. And two, keeping my team focused on the problem that we are trying to solve, and always, have that big writing on the wall. Whatever the goal is for that in that point of time, whatever that goal is, make it, shiny up on the wall and always point to that so that people can refer to it and say, today I'm at a crossroads, right? I can solve the problem this way or that way. I want my team to have the mental framework to be able to make those decisions as accurately as possible, given a very clear problem statement.
Awesome, man. That's I think what you just described, putting the goal and making sure you understand the problem statement. I think everyone should apply that to everything we do, let alone as something as complex and such an arduous task as trying to develop a system that drives on its own. So I appreciate you sharing that. I was going to say thank you for being on. I know I got to let you get back to working on these problems, managing your team, but I really appreciate you coming on and sharing. Thank you for that. Before I let you go, a few things. One, if somebody does want to reach out to you to talk to you about autonomous vehicles, Gatik, anything you mentioned on the show, what's a good way of somebody contacting you?
LinkedIn is the best way. I'm very active nowadays on LinkedIn, so I usually respond within a day of receiving a message. That would be the easiest way to find me.
Other question is, if you could ask a future guest on this show to talk about a topic, is there a topic that you'd like to hear more about?
I really like hearing about how different leaders lead their teams. Every leader will have a certain perspective, and your podcast has a lot of them. I absolutely love hearing about different perspectives of leaders, of how they approach the problem, how they approach the solution space, how they build their system of people.
System of people. I like that. I like how you brought it all together. Engin, I appreciate you coming on. Thanks for sharing. Thank you for your time.
Thanks so much, Amir. I really enjoyed it.
Absolutely. That's all for this episode. We'll be back again. Different guest, different topic. Until then, two things. One, if you like the episode, share it with somebody else. That's how the podcast grows. Secondly, like, subscribe, leave a comment. Give me some feedback on what I can do better for you to bring you more value. Until next time, thank you and goodbye.